So let's go to the simulation. This is the RBD sim, the .NET. So my RBD packed object, the RBD, the rigid body solver, gravity constraint for the glue constraint, the collider, so this is the static collider, we are going to check that as well right now, and the ground. First thing first, we have to check here the active attribute. I don't want to make them active at the first frame, because I want to trigger the explosion whenever I want. And this is why just before here, I've created a small setup to make it the way that I want, and I transfer from this setup the active attribute. I make it match with the name ID attribute. So let's go there, and there is just here. So this is the trigger activation setup. And nothing really complicated actually. Let's check what we have here. So this is just my 4 amphoras. I have decided to pack it to get just 4 different points and 4 different primitives. I keep the name ID attribute, so that's why I transfer it there. And I decide to blast it just to isolate each amphora. So this is the 0, this is the 1, this is the 2, and the 3rd. Alright, for each amphora, I want to create the active attribute, but then as well the toKeep attribute. So what is there? So here I'm saying, so the first line, if my current frame is superior or equal to this parameter, 20, then the active attribute is set to 1. So it means that the first amphora, so the amphora 0, is going to be active at the frame 20. Alright, this is going to be active at the frame 17, the frame 14, and the frame 21. Good. What about the second line? So I'm saying the exact same thing, but plus I'm adding a new parameter here, the duration parameter. So I'm saying and the frame is inferior than the active frame, so in this case 20, plus my duration frame, so in this case 22. If it's the case, then create an attribute called toKeep equal 1. So if I check here the geometry spreadsheet, I have my toKeep at 0, right? If I go to the frame 20, now the active is 1, and here it's going to be 1 again, but here the toKeep is 0, because my duration is 2. So at the frame 20, the toKeep is 1, 21, it's still 1, and here 22, it goes back to 0. It's a kind of timing for the explosion. I'm doing that because just below there, so let's merge everything, and then delete my geometry or the packed fragment in order to just keep the points with the name ID, the active, and the toKeep attribute. So this is the null that I'm going to use to get my active attribute, just there. But here I'm blasting the point if the attribute toKeep is equal to 0. So let's refresh, and then as you can see now we have 1 point, same, and now it's another one. Okay. I am using this way because inside the simulation here I'm using some force for the exploding valve, and I want to use this timing to trigger the velocity. So our trigger explosion, and this is our out trigger explosion. Alright, so let's go back inside the simulation. Okay, so let's go with the simulation. For now, I'm just going to take off this one, maybe this one as well, and those one. Let's see what we have. Oh, no, like this. Okay, so this is the fragment, and there is nothing except the activation. I mean the active attribute. And if I take off not you, but this one, then it should not move, because it's not going to be active, or everything is active actually. Okay, so let's set it back, this, and let's check the parameters. So inside the parameters, I have this one in order to overwrite the attributes. I don't think I've turned, yeah, I've disabled the enable sleeping, just in case. I don't think it's really necessary to turn it off, but just in case. This one as well, create convex hull per set of connected primitive, because let's take a look to the guide geometry. I don't want, not you, sorry, I don't want to display the geometry, just there. Okay, if I don't turn that on, this is what I'm getting, and as you can see there, this is not what I want. The collision is not going to be correct. So let's use it, and that's it. Maybe, yeah, I've decreased a bit the collision padding to get something a bit more accurate. I think it's 0.02, yeah, the default, and just to make it more accurate, 0.005. Okay, yeah, it's all right. Let's display and not see the guide geometry, like this. What about the rigid body solver? I think I didn't change. Yeah, use implicit drag. Actually, I don't know why. Sometimes I use it and sometimes not. In any case, it's not a big deal. You can turn that on if you want. What about the gravity? The default one. Alright. Let's activate the ground plane and let's make it visible and see what we have. Okay. Okay. Good. Now let's activate the constraint, and if I take this off, you can see here the glue constraint from the second input based on the glue name with a strength of 100. Let's see what happened. Up. Yeah, this is what I want. I want most of them falling, and then when it's colliding the ground or the amphoras, then it's finishing to break, you know. It's not the case there because the impact is not that much, but I've done it with the explosion force, so it doesn't work now, but with those, yes. So let's connect it. Let's go with, so let's connect this one to this one. So this is my first node. This is just an edge attribute that I compute from the activation. So if it is active, or if the attribute active is equal to 1, then h from active plus equal 1. So nothing complicated. And then those four are the same, but the difference is 1 node per amphora, per object. So this is the name ID 0, the 1, 2, 3. So let's disconnect those one and just use the name ID 0, which is not sure. Actually, yeah, let's go back and let's see why I have got this blast. This blast is used to prototype my simulation, and let's say I want to isolate the name ID 0 to get a quicker feedback. So let's go there, and now I know under which one I work. So let's see the result. Yeah, something like this. Good. So let's see how I get that. First of all, I'm using this operation, or I compute this operation only for the name ID 0, and it's a pop-up. So let's dive inside. I'm setting the velocity here. So I'm computing two different two different vectors. The first one is a kind of repulse force, this one. And the second one is a curl noise. But since the explosion is going to be active for 2 frames, then if I set the position as a reference, the vectors are going to change. And I will get something very weird actually. And this is why I need to use the rest position as a reference. And that's why as well we have added the rest node here. Alright, so let's go back and see what we have. So if you remember, I'm looking for the near point, but the near point of the second input, which is the out trigger explosion. If I go there, it is, if you remember, my amphoras there that I've turned into points and primitive there, but here it's just only points. So this is the output that I'm looking for, and we can check here. There are just points. So let's go back. So I'm looking for the near point, taking the position of it, and subtract my current position to this one to get like an explosion force, or a force going, not a force, sorry, a vector going in this direction, and there, and there, and there. And we can actually check that. Let's see. With the normals. Not you. But it's not visible because it's packed. But yeah, if I zoom there and I take the center of the fragment piece, then it's going to compute the vector from this position to this position, and then the fragment is going to move this way. So using some operation after to limit or reduce the y component, because I don't want to go a bit extreme in that position, or in the y axis. I'm using as well the distance from the point to multiply my normalized vector that I remap. It means closer it is, stronger the velocity will be. And I can specify the radius there, just here. Oops. I'm just adding the curl noise to the repulse vectors, and I'm adding those vectors, let's take off this one for now, to the previous velocity, to inherit from the previous frame. And that I plug that to the new velocity. I multiply those vectors to some operation, which is like a kind of security. And I'm saying if it's not the correct name ID, then don't do anything, or if there is no near point, then don't do anything as well. And that's it. So let's go back and active those one, because this is the same thing for the name ID 1, but it's not the same parameters, because this is a good way to prototype and then just get exactly what I want artistically wise. Alright, but then here it's name ID 1, here it's name ID 2. So let's continue. Here, I was not really happy with the rotation of the object, actually. It was a bit too static or too linear, and that's why I wanted to increase a bit the angular velocity by adding some random rotation, but only at the beginning of the explosion. So if my edge is inferior than 3, less than 3, then there will be nothing, and I'm using the ID that I randomize. The add here is just a seed if I want to change and try different value. I'm just fitting here because the random is going to give me a 3D vector, but the value will be between 0 and 1, 0, 0, 0, and 1, 1, 1, 1. And I want to remap between -1, -1, and 1, 1, 1. Alright, don't forget to add that to the previous angular velocity and to export the new angular velocity. And here I can just increase the amount, and here change the seed for a different rotation. Good. And here I'm just adding a drag over the angular velocity. So when it's exploding, I want to wait 10 frames, and then after start to decrease the rotation, the angular velocity, by 3% each frame. Alright. So let's go there, and I wanted to check something with you. Let's see the result first. Yeah, okay, good. And I wanted to check, here this is the DOP import that I'm using to create points to represent objects of the RBD. And that's why I just have points here. I'm not going to use those one, but just the one that I'm simulating right now, because I want to check something with you. And this will be, yeah, that's good. Oops. Okay. I wanted to check with you the retime. So if I use the retime right now, and I go a bit later, up, let's take out the texture and zoom a bit more. As you can see, it makes something very weird at the beginning. And this is because I am using the linear interpolation with the velocity. Alright, if I take it off, as you can see, now it's just exploding normally. Yeah. And before it was going back like something weird, you know? Yeah. And this is because the velocity is not correct. So there are a couple of ways to modify it. But a good one is just to, instead of using the post-solve operation, you can just use the pre-solve operation. And then if I check it, now it's correct. Let's see if it's, yeah, it's there. So now I have my correct interpolation with the velocity, but the velocity are correct for the interpolation. So this is good to me. I could also use a trail or whatever, or compute directly the correct velocity inside the DOP. So this is a way to do it. So let's go back to the cache. There, I don't want to use only one amphora, but 4 of them. Let's check if I have everything. No, I don't have the static objects. So this is the collider. Let's dive inside and see what we have. So if you remember at the beginning, we were there. Okay. And if I invert the selection, I have all the static amphora. So this is what I'm looking for. I'm using a material to set the material here. And this is the input that I'm going to look for inside my render node. So if I go there and inside the render amphora, this is the out static amphora. So this one. And here I just want to create a better collider for my RBD simulation. I don't want to go inside the amphora, so I would like just to close, you know, the hole. And this is why if I isolate one single path, I'm just blasting the inside original, if you remember, and then use a polyfill with the mode quadrilaters, even though I could use the triangles. But let's go back to quadrilaters. And once I have that, I'm just using a convex decomposition. Maybe I need to refresh. No, it seems to be correct. Good. Yeah, it is. So I don't want to isolate it. Alright, and then I can just feed my static collider directly inside my simulation. By the way, I could use an RBD packed object, another one, or merge the active fragment with this one, but I can do that as well. Use a static object. It's not going to use the RBD solver, but the bullet data. So let's see what I have there, and I'm going to use those as guide. I don't even need to feed with a packed object, but then I need to create convex hull per set of connected primitive. All right. So this is going to be static, and we can hide that. Good. And if I go directly here, this is the result that I have. Step 1. Yeah. So nothing special, nothing complicated. Let's see what I have with the retime. So for the retime, I'm using the by speed, and I've animated the speed parameter. You can see the keys here. Let's see that. So this is the speed that I want. The 1 is real time, then it's 0.05, so 20 times slower, and then it goes back to 1 at the frame 125. All right, I'm using the interpolation linear with the velocity, and I'm scaling the velocity as well in order to get the correct motion blur. Okay, so let's see what we have. Step 2. So this is our simulation with the retime, with the slow motion. I think it's good enough. Yeah, so let's continue. And actually that's it for the RBD setup. This is the output that I'm going to use to render my simulated enforage. And this is the real-time output that I'm going to use for the collider, for the flip simulation. But let's check that on the other setup.